Cool. Hi. Hey, it's late, but it's not over yet, so be perky. So if you haven't tracked Angular for a while, we've been recovering from AngularJS to Angular transition, and our community's actually grown, bigger than the AngularJS size was. This late last year, we passed 1 million developers on our doc site 30-day active, so we're pretty excited about that. That was coming. Kind of cool. Angular comes with a whole bunch of features out of the box that work together. One of these features is Angular Universal that lets us do server-side rendering in Node.js. And one of the nice things about having all these features come from one place is they're actually going to work in the client, but also on the server. And the way this kind of works is if you want to run Angular on the server, when a request comes in, you can actually run the entire application where you merge data with your templates on the server and just send back a static rendering of your application so that first view can be done faster. We'll talk about why a little bit more. And then your actual application can come down, your full JavaScript version, and then take over from there as a single page app. So why would we do this? Well, a couple reasons. Number one, if you want to have previews that appear in things like Twitter, Reddit, Facebook, those sites, they don't run your JavaScript for you. And so if you want a preview of them, you're going to have to run that JavaScript on the server and get it rendered for them. Second is speed. For that initial view, so you don't have to wait for the JavaScript to come down. This can help a lot. We'll dig a lot more into that later. And then for SEO, if you're these search engines, a lot of them do run your JavaScript, but the results can kind of be inconsistent, so this can be very helpful for giving them a really accurate view of what your site's about. So if you want to be good, fast, or popular, maybe server-side rendering could be for you. So I've got an example app that we'll share the source code with, but you kind of get what it does. You can scroll through some Google logoware and buy things, as we all need to do. And when we put this, I'm sorry, there's a couple of these, when we put this in Google, the Chrome Lighthouse tool, and look at the performance of this particular app, and also when we simulate a 3G connection and kind of a slow device, you see that the first meaningful paint is, okay, it's not horrible, but really not too great. Where users start falling off at about 2 seconds, we're kind of closer to 3 seconds, and the interactivity when the JavaScript actually kicks in is about a little over 4 seconds. We can do better by doing server-side rendering, where we notice that in comparison, first meaningful paint gets a lot better, dropping down to just over a second. But my first time to interactive is actually worse. It's up almost a second longer, about 5 seconds, because we had to download that HTML first, and then get the JavaScript down and render that. So we were thinking, well, what can we do about this? And I would kind of describe the problem as my interactivity just starts too late. And one of the strategies that we came up with for this is something I call incremental activation, where we can, as a developer, declare, hey, some of parts of my application are actually more important than others, and I want them to start first for my user. Well, how can we do this? Well, one of the technique we came up with is using a part of the web components standard called custom elements. And what we have in the latest version of Angular is the ability through this thing called Angular Elements to turn any of your Angular components into custom elements. And what that means is they look like any other DOM element. You can set properties on them, and you can get events out of them. And that means that any piece of JavaScript knows how to interact with them. It doesn't have to know Angular. The cool thing about it is we actually don't have to ship down any code for bootstrapping. This is part of most browsers. We did a polyfill for some of the others. But for most browsers, this just runs immediately. And so then if we look at our application, we might say, well, there's a couple things that we care most about. Like, I want to be able to scroll this thing once it comes in. I might want to be able to add things to my cart and then get some acknowledgement that things have been added to my cart. And so when we turn these things into Angular elements, and we just bootstrap those without downloading the routing and the animations and all the other stuff that we'll want for the full app, we actually get a really good sort of mixed result, where the first meaningful paint is up just a little bit, about 1.4, but that first time to interactive for those parts of the application comes way down, and users, even on slower networks and mobile devices, they can get a pretty good experience. And just in comparison to about 3 seconds and a little over 4 seconds. And we can try and play this just so we can see how this kind of feels. On the right-hand side here, we can see the fun, happy hybrid app where I can automatically see what's going on almost instantaneously, start interacting long before the original site was ready to go. Okay, so you can get all of this code. I'm not going to go through it. This is the lightning talk. You can get all this code, and I'll share a link with you so you don't actually have to write that down at the end of the talk here. One more sort of sneaky solution that I'll share is, hey, you know what? Google is not yet a Node.js shop. We don't know that much about it, running in production. Our SREs aren't familiar with it. And so we on the Angular team, we wanted to change this, and so we were going to be sneaky, and well, could we just pretend that it was something you already know how to deal with? And we're like, well, maybe. Well, what do you know how to deal with? Okay, well, how about Java, C++, and Go? It's like, okay, so we're just going to make it look like any other binary. And how we chose to do this is, we want to run Node. And the team, well, the first team we're going to launch with, I've already written their application in Java. They're not going to go rewrite the thing. And so what we did was we wrapped Node in Go. You could wrap Node wherever you want. It's not important for this part of the story. But what we did is we put this nice management interface around Node.js as our sneaky way to get in, so that when the request comes in, now Java just conjures up the data that it pulls out of the data store, or whatever it's going to do. Go runs our Angular application, and we return the response. Nobody's the wiser. We're going to be launching some of this into production with a couple teams this year, and we'll say more about that in a minute. You can see more about this at a talk that we gave earlier this year. And Vikram, who's the lead engineer on this, is going to be talking at Node Summit. And I think hopefully going to reveal a lot more of how we do this at Google and about these techniques that we're working on. One final note, we do really want to bring down this time to interactive in Angular. And if you are the smartest, most knowledgeable person about Angular, you can kind of get the size down to about 36K, which is, it's okay, it's not where we want to go. We're working on a new renderer called Ivy, and Ivy's claim to fame is it's just smaller, but it tree shapes, meaning dead code being eliminated much easier than our current environment. The current prototype is a Hello World coming in at about 7.3K when unified, and about 2.7K compressed. So we really, we're really hoping to bring down those time to interactives as well. My talk, all the slides are up at bit.ly/WorkerSSR. Thanks so much.